So I want to go back over what we were talking about in regards to half angle and double angle identities in the steps as we continue our notes from yesterday. And I just want to remind us of our steps. One of the most important being we need to determine what quadrant we're working with. And that's what our first step says. Determine the quadrant that the triangle is in, and then we need to sketch it. The nice part about these types of problems compared to our sum and difference is that there's only one triangle. We have to use the Pythagorean theorem to find any missing side lengths. Then we have to determine which formula that we're going to use, and we're going to have to probably flip back and forth there, but our formulas are on the top of our front page. We're going to use the triangle to replace. So once we figure out the values, once we figure out what sine of x equals, we can replace that entire amount with that. And that didn't come out very well, but we'll see that when we go through our examples here in a couple minutes. But I wrote it. The entire sine of x gets replaced with the ratio, with that fraction. Don't just replace the variable. The whole function gets replaced. There should be no trig words left. And then simplify. And if we have to, we're going to have to get rid of the radical in the denominator. Sometimes we end up with the radical in the denominator, sometimes we don't. It's the same exact process as we did with the sum and difference identities, but again, only one triangle. So if we flip over here to the back, I did leave enough space, I believe. But I'm going to scoot this and make it just a little bit more of the same format as you. And I'll write in the same places that I wrote them. But here's what we've got. We've got find cosine of 2 theta, tangent of 2 theta, sine of theta divided by 2, and tangent of theta divided by 2. We need to write all our answers in simplest fraction form or simplest radical form, both, really. But the first thing that I look at and think is most important is this part right here. Pi over 2 is less than theta is less than pi. And if we need to, we can go back and label our quadrantals in our coordinate plane here. Here's 0. Here's pi over 2. Here's pi. Here's 3 pi divided by 2. And when we come full circle, it's 2 pi. So if we can label our quadrantals in there, what we see is between pi over 2 and pi over 2 and pi, we're going to be working in the second quadrant. And then we need to draw a triangle. Remember that our angle connects back to the origin. Ooh. And not my most right triangle, but you get the idea here. Again, our angle is here at the origin. What we're given is the fact that cosine is negative 2/7. And we need to find some other information. But just a reminder, that sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. And tangent is opposite divided by adjacent. So when we fill this in, or we look a little bit more closely here at this, what we've got is across from our right angle is the hypotenuse. And across from our angle is the opposite. So our x-axis part of the triangle is our adjacent. And once we know that, we can label this triangle based on the fact that we're given the cosine of theta is negative 2/7. Cosine being the adjacent divided by the hypotenuse. So if we look real close here, in the second quadrant, cosine is negative. Hypotenuse is always positive. And in fact, we're going left with our triangle, which is why we can put that negative in. So once we have our triangle labeled, we need to use the Pythagorean theorem to find, in this case, our opposite length. So it's going to be negative 2 squared plus x squared equals 7 squared, and it doesn't have to be x, it can be some variable. Negative 2 squared means negative 2 times negative 2, which is positive 4, plus x squared and 7 squared is 49. Well, we want to figure out what x equals, so we're going to move the 4 to the other side by subtracting. We get x squared equals 45. And the inverse operation of squaring is square rooting. So we end up with x equals the square root of 45. But that's not in simplest radical form. So we're going to break down the square root of 45 into two factors, potentially like 9 and 5. There's nothing wrong if you use 15 and 3. And then we're going to break 9 apart into 3 and 3. And in fact, 45 is 3 times 3 times 5. When we simplify a radical, we're looking for two of the same value to take out 1. So the square root of 45 is 3 radical 5. 2 3's, we took out 1. Then we'll keep the radical 5. We have a single there. And we can put that value back in our triangle here. Once we have the values of the triangle, then we can identify. We know cosine of theta is negative 2 over 7. Well, what's the sine of theta based on this triangle? 3 radical 5 over 7. We know cosine. Let's also identify what tangent is. And tangent is the opposite divided by the adjacent. So tangent's going to be 3 radical 5 divided by negative 2. And the negative 2 doesn't have to be in the bottom. It can be in the front of the fraction if we prefer. But we don't need tangent right now to figure out what cosine of 2 theta is. But if you flip your paper back over and you look at the cosine of 2 theta identity, it tells us that we're going to work with cosine squared of theta minus sine squared theta. So we need to identify what the different function values are in this triangle so we can fill it back in. The nice part is we were given cosine. Cosine is negative 2/7. And we're going to square it. We just figured out what sine is, and it is 3 radical 5 divided by 7. And we're going to square that as well. Cosine squared minus sine squared. If you have an up-to-date calculator, the calculator will calculate that value. If you go, I don't know what that is. Now, in the effort of saving a little bit of time, negative 2/7, if we square negative 2, we get 4. If we square 7, we get 49. And your calculator will do that. And actually, as I think about it, why don't I show you that we can figure this out in our calculator? If we type in 3 square root of 5 divided by 7. And then I wish I would have put parentheses in there. It will still work here. But I'm going to put the squared on there. And so we get this big long decimal, which isn't very helpful. But if you go to math, enter, and enter, we should get a fraction, which is what we want, because we want to put our answer in simplest fraction form or simplest radical form. So again, our calculator will calculate that value, and we get 45/49. And once we have that, we have a common denominator already. 4 minus 45 is negative 41 divided by 49. So I'm a little bit tight on space here, but I still think that we can squeeze it in. Just trying to separate it out a little bit. And the tangent of 2 theta, again, if we look back on the front page of our paper, it's 2 tangent of theta divided by 1 minus tangent squared of theta. So this time we're going to use our tangent function. I did kind of overlook one thing that I want to mention. In our second quadrant here, tangent is negative, which is why our value, tangent theta is 3 radical 5 divided by negative 2, it's negative. It's a little checking point because all students take calculus. So in the second quadrant, our only function that's positive in the second quadrant is sine. But we have that value here, so we're going to fill it in. So this is going to be 2 times our tangent, once again, which is 3 radical 5 over negative 2. And then it's divided by 1 minus 3 radical 5 over negative 2 squared. If we simplify a little bit, and I know it's jumbled up, it's not quite so jumbled on my paper, but it's jumbled up here on the board. When we simplify this one, if you notice, and some of you will, there's a 2 in the top of the fraction, there's a 2 in the bottom of the fraction, they can cancel out. But if you don't notice that, then we can multiply straight across. The numerator times the numerator, top times top, bottom times bottom. 2 times 3 is 6 radical 5. And then 1 times negative 2 is negative 2. That's what's in the top of this identity when we fill it in. Down here in the denominator, this is where we might want to type that in. So it's 1 minus, here's our fraction, and I'm going to actually try to put parentheses in this time. 1 minus, and then we've got 3 radical 5 divided by 2, negative 2. And then when I close the parentheses and square it, did I get that right there? Checking me? So when we press enter, once again, even though it's a decimal, we can hit math, enter, enter, and we get a fraction there, negative 41 fourths. So here's the negative 41 fourths. So finally, when dividing, don't ask why. Flip the second one and multiply. So we end up with 6 radical 5 divided by negative 2. And when we divide this is the second one. Sorry, I didn't say it. When we're dividing by negative 41 over 4, that's the second one. When dividing, don't ask why. Flip the second one and multiply. So getting close here to finishing. 6 times 4 is 24 radical 5. Notice that we multiplied the coefficients. We left the radical alone. Down here in the denominator, negative 2 times negative 41 is 82. And we want our answer in simplest fraction and or simplest radical form. We can simplify the 24 over 82. And if you can't do that in your head, yet again, you can go and use your fraction button here. 24 divided by 82 will give you the 12/41st, which is 12 radical 5 over 41. And that's our value of tangent of 2 theta. Those were the double angles. We saw the double angles yesterday. We see the double angles today. Gonna finish here with the half angles. And I put our triangle here. I don't think that we necessarily really need this, because if we think about what sine of theta over 2 is, and we flip back and we look on the front page for our identity, the sine of theta over 2 is plus or minus, it's 1 minus cosine of theta divided by 2. I've kind of gotten ahead of myself, but the reason why I don't really need the triangle here is because our given information is in terms of cosine, so we have everything that we need. But what we also need to figure out is our answer going to be positive, or is our answer going to be negative? Because we've got this plus or minus in front of the square root symbol, and it's either positive or it's negative. It's not both. So if we look up here at what the words say, it says determining whether the half angle identities will be positive or negative is more challenging with these types of problems than it is with the unit circle problems. But in this case, consider that the original triangle is sketched above in quadrant 2. So I've got the picture there. Here's maybe a better way to think of it. If we think about this, pi over 2 is 90 degrees. And pi is 180 degrees. But what we want is, we want to pick values that are within the quadrant. So 90 and 180, those are quadrantals. So what if we look at 91? That's in our second quadrant. But if we divide 91 by 2, what do we get? We put 45 and a half. What quadrant's 45 and a half in? Quadrant 1. Hang on. And then if we take 179, I'm running out of space here, and we divide by 2, well, what's 179 divided by 2? It's 89.5. What quadrant is that in? It's still in quadrant 1. So when we look at this, our answer is going to be in quadrant 1. And is the sine in quadrant 1 positive or negative? It's going to be positive. So this value, I'm going to write that big red positive on top of my plus or minus. And that's essentially what it says here. It's easier to think of these types of problems in terms of degrees. And I know some of you might be like your teachers who have to step back and go, oh, degrees for a second, because we're so used to radians. But think of it in terms of degrees. Pick any angle in the above range. That's why I pick one more than this value and one less than that value. One more than 90, one less than 180. And then divide it by 2 and see what quadrant those angles end up in, because that's going to determine whether our answer is going to be positive or negative. So now that we've got that, like I said, now that we know it's quadrant 1 and sine is positive in quadrant 1, we can fill in the rest of this. So now we've got the square root of 1 minus, well, cosine of theta is given to us. It's at the top of your page. I just put it in, screenshotted it into this page here. But this is going to be 1 minus negative 2/7 divided by 2. Well, double negative gives us a positive. And if you need to, use your calculator. But 1 plus 2/7 is 9/7. 1 is the same thing as 7 over 7. And if you need to, type it in. 1 plus 2/7. Well, once again, this is 9/7 divided by 2. And you can type that in as well. But 9/7 divided by 2, when dividing, don't ask why. Flip the second one in, multiply. So we end up with, which is not around 9/14. 9 times 1, 7 times 2. But if we think back to the directions, the last set says, make sure to rationalize the denominator if necessary. It's necessary this time. So we've got the square root of 9 and the square root of 14, and notice how I separated that fraction into 2. We're allowed to do that. Can we take the square root of 9?
Yeah.
It is 3. So now we have 3 over the square root of 14. We want to get rid of the radical in the denominator. So we're going to multiply it by itself. By multiplying by radical 14 here, multiplying by radical 14 here. And what we end up with is we end up with 3 times the square root of 14. 14 times 14 is 196. But if we take the square root of 196, we still get 14. We have 2 of the same to take out 1. And that is our sign of theta over 2. It is positive because our function ends up in quadrant 1. So to finish here, let's look at tangent of theta over 2. And I am going to scoot this over a little bit so we can see it. I need to revise these smartboard notes just a little bit for next year. But the tangent function, if we look back on the front page here, the tangent function, is it 1 minus cosine theta over 1 plus, or is it the opposite? I gotta look. And we're not expecting you to memorize here.
Yeah, that's
Whew, I'm trying to remember. Technically, in terms of the identity, it's plus or minus, but we've already determined that this value, theta divided by 2, is going to end up in quadrant 1. So ultimately, when we finish this, we're going to end up with a positive value. That's why I write that blue positive on top of the plus or minus. We already know what cosine is. We're given that value. Cosine of theta is -2/7. So we're going to put that back into our function here. So it's going to be 1 minus -2/7. And down here in the denominator, it's going to be 1 plus a -2/7. And if we simplify that a little bit more, minus a negative gives us a plus. And down here, and actually let me just write it on a separate line here because it's not writing very well. We get 1 plus 2/7 divided by 1 minus 2/7. In the top we had negative, negative, so it became positive. In the bottom of our fraction, in the denominator, it was 1 plus a negative, and positive times negative is negative. Once again, if you need to, type in 1 plus 2/7 in your calculator, if you have to. But hopefully you end up with 9/7 when you do. And down here, 7/7 minus 2/7 is 5/7. And those values are still underneath the radical. And in general, I tend not to even write that step right there. I tend to write it as 9/7 divided by 5/7. And one last time to hear me say, when dividing, don't ask why, flip the second one in, multiply. Again, you can even type that into the calculator. But what happens is the 7's cancel out. We end up with the square root of 9 over 5, which is similar to what we just had in that last problem. Remember, we're able to break it apart. We're able to rewrite this as the square root of 9 divided by the square root of 5. And we can take the square root of 9. But we can't take the square root of 5. So to finish for today's notes, what we're going to do is we're going to rationalize the denominator. We're going to get the radical out of the denominator. And we do that by multiplying by whatever's in the denominator. Radical 5 divided by radical 5 is actually 1. So there's our fancy form of 1. We end up with 3 radical 5 divided by 5. 5 times 5 is 25. The square root of 25 is 5. One last reminder. We determined it early on. Our fraction is positive because when we divide by 2, we're working with an angle in the first quadrant.